Hi ladies, today we're going to talk about proving lines are parallel. Our last video we talked about angles that parallel lines create. Now we're going to talk about the angles and why they make those lines parallel. So we're going to be talking about the converse of all the different angle theorems that we learned. The first one says that if two lines and a transversal form corresponding angles, angle 2 and angle 6 are corresponding, and they are congruent, then the lines are parallel. So I'm proving that line L is parallel to line M because 2 and 6 are congruent and they are corresponding angles. The second theorem that we talked about was the alternate interior angles theorem. And we know that alternate interior angles are on opposite sides of the transversal and in the interior. So this theorem says if two lines and a transversal form alternate interior angles that are congruent, then the lines are parallel. The next one is actually a postulate. This says that using same side interior angles or consecutive angles, they're on the same side, if the two of these angles equal 180 degrees, then they must be same side interior, then the two lines must be parallel. If two lines and a transversal form same side interior angles that are supplementary, meaning that they equal 180 degrees, then the two lines are parallel. The next theorem we're going to talk about is the converse of the alternate exterior angles. Remember we said that alternate exterior are on the exterior and are opposite sides of the transversal. So if two lines and a transversal form alternate interior angles that are congruent, then the two lines are parallel. So we know that these two angles are congruent. We have two lines in a transversal, so line L must be congruent to line M. The next thing we're going to talk about are comparing parallel lines to each other and to perpendicular lines to come up with some conclusions. So if two lines are parallel to the same line, so if A is parallel to B, and B is parallel to C, then A is parallel to C. Doesn't that sound like the transitive property? So any two lines that are parallel to the same line are parallel to each other. Our next conclusion is if in a plane two lines are perpendicular to each other, meaning they form a 90-degree angle, then they are parallel to each other. So we're saying that these two lines are perpendicular to the same line, meaning we have a 90-degree angle at the top and a 90-degree angle here. So if they're forming two 90-degree angles, these lines must be parallel to each other. The last theorem we're going to talk about is the perpendicular transversal theorem. In a plane, if a line is perpendicular to one of two parallel lines, then it is also perpendicular to the other. So if we have two parallel lines here, and our transversal is perpendicular to the first line, it must also be perpendicular to the second line. And you can think of that as corresponding angles. Angle N corresponds to this angle here, so they must have the same measure. So once again, if I have a line is perpendicular to one of two parallel lines, then it is also perpendicular to the second line.